Oh, there's Dr. Romano. Gotta ask him a question. Hi, Dr. Romano. It started raining outside when I left. Do you have an umbrella I can borrow?
No, good day to you.
Are you still working, Dr. Romano? What's going on here?
All right, come on around. Have a look what I'm doing. We're working on a question for the DAT. I'm always developing new questions and concepts.
Okay, I guess I'll stay here till it stops raining.
What I want to do here is to see which mechanism is incorrectly stated as operating. This is a very important question for the DAT. You should get two things out of this tape. You should know how to complete the products and understand which mechanism is under consideration. First thing I see in ketone, and it's reacting with a primary amine. Whenever you see a ketone and a primary amine, you're going to form what's called an imine. You split off the water. And the mechanism is known as an addition-elimination mechanism. Notice if you can envision the nitrogen doing a nucleophilic attack, and then the water would leave with the oxygen, and that would be our leaving group. So this is an addition elimination. Let it be as a slam dunk. We have a very strong nucleophile. We have a good leaving group, polar aprotic solvent. This is the SN2. Notice in the SN2, I did an inversion of the configuration. So that looks good. In letter C, I have a secondary halide again, but the base is strong and powerful. If the base is strong and powerful, or in this case, this is still a nucleophile, but I can also use the word base, whenever you have a secondary halide with an ethoxide or a methoxide or an amide, what you're going to do is you're going to do the E2 reaction, and you're going to form the more substituted alkene. So letter C would be E2 Zaitsev elimination. And notice the stereochemistry shows the trans isomer is the major product. Letter D, that's an easy one. This is simply a radical substitution. If you look at the 2-methylbutane, what we do is remove off the tertiary hydrogen, and we simply replace that hydrogen with a bromine at the tertiary position, and that would be a radical substitution. The minute you see HV, that stands for ultraviolet radiation, you're going to think radical substitution mechanisms. That'll usually be the norm. They're all correct so far, but the last one, this is showing me an acyl halide being reacted with an alcohol. Now, the minute you see nucleophilic addition, you should sort of say to yourself, that's usually the mechanism for an aldehyde or a ketone. And this is not an aldehyde or a ketone, but an acyl halide. So, as you can see here, this is going to be the answer that I'm looking for. This is incorrect. This is not a nucleophilic addition. But if you see an acyl halide, they usually undergo a reaction known as a nucleophilic acyl substitution reaction. So the correct answer that I'm looking for is choice E, because that is incorrect. This reaction, and by the way, whenever you have an acyl halide, as you can see what I'm going to do, I'm going to split off HCl. And when I split off HCl, if I want to put a little catalyst underneath it or a solvent, PYR, the PYR will be used to neutralize the final HCl, so it won't come back and hydrolyze my ester. But the bottom line is this reaction is a nucleophilic acyl substitution. All right, I hope that helped. There was a lot of chemistry on that. So you needed to not only know the reaction mechanism, but understand complete the products. And this one little tape will be very valuable for when you go for the DAT exam.
Thank you, Dr. Romano. That's a nice hat. Could I borrow that for a little bit so I don't get wet?
We'll be seeing you. Good day to you.
Are you leaving, Dr. Romano? Goodbye, Dr. Romano. Good day to you, sir.